Hello everyone, so in this video we are going to solve a question of LeetCode, that is check if there is a valid partition for the array. So let's start with the problem statement. You are given a zero indexed array nums. You have to partition the array into one or more continuous subarrays. So basically we have given an integer array and we need to partition this array into one or more continuous subarray, right? And we have basically given three valid statements and we need to partition the array based on these three statements. So the very first statement is there must be exactly two equal elements in the subarray, right? And the second statement is there must be exactly three equal elements in the subarray. And the third statement is there must be exactly three consecutive increasing elements in the subarray, right? So if any of the three statement is valid for the subarray, we can consider that subarray as a valid subarray. And at the end, we need to return if array has at least one valid partition, right? Otherwise we need to return false. So let's quickly see the first example. So in the first example we have 4 4 4 5 and 6, right? So let's quickly see this example here. So the first example is 4 4 4 5 and 6, right? And the three valid conditions are, the first condition is two equal elements must be there, right? Then the second condition is three equal elements must be there in the subarray, and the third condition is three continuous increasing elements must be there, right? So let's check these condition. The first condition is two equal elements must be there, right? So let's take the first two elements and they are equal. It means this condition is satisfied. Now let's see for the remaining one. For the remaining one, 4 5 and 6, the first two elements, let's see the first two elements, they are not equal, so this statement is false for this one, right? Now let's see for 3, right? So for these three are not equal, then this statement is also false, right? Now let's see for the third one, three continuously increasing elements must be there, right? So these three are continuously increasing, 4 5 and 6, so we can consider this as a valid condition, right? So in this case we got two subarrays, two valid subarrays, and we have covered whole array, right? So it means this is a valid sequence, right? So in this case we need to return true, right? We need to return true. So what we are basically doing is we are just checking the conditions for each subarray, right? We are just checking the condition for each subarray. So how can we solve this question? Right, so we can easily solve this question by using a recursive call. We will check for two equal elements, then we will check for three equal elements, and then we will check for three continuous elements. And if any of them is true, then we need to return true. So what is the possible operator we need to use here is, we need to use OR operator here, right? Because any of them must be true, right? So if any of them is true, then we can return true from here, right? So let's quickly write the recursive call for this, then we will memorize the solution, right? So let's quickly write a recursive call for this. So for this, let's make a function that is bool, and let's make solve. Let's take it here vector of integer nums, and also take int I, which will be starting from 0. So let's call this here. So return solve and nums and I is equal to 0 initially, right? Now what we need to do is we need to check all three statements, right? So let's check the first statement. If nums of I is equal to nums of I plus 1, right? So if first two elements are equal, and also check whether this I plus 1 is going out of bound or not, right? So for this, I plus 1 must be less than nums dot size, right? This also we need to check, because if this goes out of the bound, then our program will give us error. That's why we need to check this before checking this statement, right? So in this case, what we need to do is we need to return true, right? So before this returning true, what else we can do is, let's take a bool variable here, bool, let's take a flag and initialize it with false, right? Now let's write flag is equal to, and let's call recursive call for this solve for the remaining part, right? Let's say we have already got a true for this, right, for these first two elements. Now we need to call for the remaining one, right? So let's say we have the indices as 0, 1, 2, 3 and 4, right? So we have just covered till here, right? So what we need to do is we need to add I plus 2, right? We just need to call this because initially I is 0, right? And we need to call for this remaining one. So 0 plus 2 is equal to 2, so this will be calling a recursive call from here, right? So let's call this solve nums and I plus 2, right? And let's take or here because any one of the condition must be true, that's why we are taking or here, right? So let's take this here, flag or solve, right? I hope this is fine. Let's see for other conditions. I plus 2 must be less than nums dot size. Now we are checking three elements, right? First three elements. So nums dot size and nums of I must be equal to nums of I plus 1, and nums of I plus 1 must be equal to nums of I plus 2, right? So if first three elements are equal, then also we need to call for the next elements, right? So in this case, let's take flag or solve nums I plus 3, right? Now we are just starting for the this one, right? We are just starting for this. Let's say we have taken first three elements, so this should be I plus 3 because this is the third index here, right? So this is fine. Now let's call another one for three continuously increasing elements. So for this, let's write I plus 2 must be less than nums dot size, and also check nums of I must be equal to nums of I plus 1 minus 1, right? Because there must be only one, they must be like the adjacent element, the difference between adjacent element must be 1, so that's why we are just subtracting 1 from here, right? And nums of I minus I plus 1 is equal to nums of I plus 2 minus 1, right? And let's update our flag with flag or solve for the next element, so nums I plus 3. All right, I hope this is clear to you. And also take boundary condition here, if I is exceeding the limit, so if it is going out of the bound, so I is greater than equal to nums dot size, then in this case we need to return true. It means we have completed the iteration of whole array and we need to return true, so this is true. And at the end, just return flag from here. So this is basically returning the result of these three statements. And let's try to run this on sample test cases. This is basically a brute force approach using a recursive calls, then we will memorize this, right? So this is a brute force approach and this will give us TLE in higher values, right? So let's try to memorize this. So what we usually do in memorization, we make a DP array. So let's make a DP array int DP of, let's say DP, let's take the higher limit. So higher limit is 10 to the power 5. So let's take 1 2 extra. So we have 1 1 1 2 3 4 5, and let's take one extra here. All right, now let's set all the elements of this dp to -1. This is a classic approach which we do in conversing from recursive calls to memoization, right? So meme set dp -1 and size of dp. All right, and now let's store this flag answer into dp of I, and here let's check if dp of I does not equal to -1, then we need to return dp of I from here, right? So it means we have already computed the value, so we need to return dp of I from here, right? So I hope this is fine. Let's try to run this. Yeah, it's running fine. So let's submit this, then we will discuss the time and space complexity. Yeah, so the time and space complexity of this solution is, time complexity is bigger of n, because we will be traversing through at max n elements in this recursive call, because we are already storing the values in this dp. So we are just eliminating the sub problems here, right? We are just eliminating the sub problem. That's why the time complexity is bigger of n. Otherwise, if we have not taken this dp array and we have been doing this problem through brute force approach, or the classic recursive call, so in that case the time complexity would be 3 to the power n, right? Because we have three conditions here and we have n elements here. So in that case the time complexity would go up to 3 to the power n. But in this case we are just using a memoization, so in this time complexity is bigger of n, right? And the space complexity is also bigger of n, because we are storing n elements into this dp array, right? So that is it for this video. I hope the approach and solution is clear to you. If you still have any doubt in this question, feel free to comment down. Please like this video and subscribe to our channel. I will see you in the next video.